Probability with Permutations and Combinations by Justin D'Souza. The learning objectives of this lesson are to use permutations to compute probabilities and to use combinations to compute probabilities. The keywords are permutation, factorial, and combination. This is a very interesting lesson because now here we will see a whole new way to find all the possibilities of an event occurring. That is from permutations and combinations. The difference between permutation and combination is very simple. Order. Wherever order is important, that is permutation. If order is not important, then it is combination. Now imagine these are the three colored balls. We want to arrange them in different ways, but where the order matters, which color is it kept first matters, the second color matters, the third color matters. In such cases, they come under permutations. Now here this is one arrangement. Now the second one, black is at first, but over here the green and the red have been swapped, right? This is altogether another arrangement. Similarly, now the red color is over here in the first, and then the other two are swapped, and lastly the green color at first, and then the other two are swapped. So here these are the different ways of arrangement of these three colored balls. This is permutations. Here the order matters, isn't it? Now each new order is a different permutation. Now here, let's imagine a situation, say you're picking up balls. Now how many different pairs can we select from these three balls? What does pair mean? Pair means any two. Okay, how can you select any two? So let's look into better understanding. See, there's one way you can select these two, black and red or red and black, because each order matters here. There are different arrangements altogether. Or you can take, say, black and green, green and black, or red and green, green and red. So these are the six different ways, right? Now this was a simple one because we're just taking pairs. But what if the sample space is huge in the sense there may be 20 balls and we are taking three at a time? It's going to be a lot of possibilities, isn't it? We can formulate this by a simple formula, NPR or 3P2, which is given by this formula over here, 3 factorial by 3 minus 2 whole factorial equals 6. Now I will show you how to exactly do that. Now before we go ahead, let's look into factorials. Now why this factorial is used is because of the fundamental counting principle. We had seen in the previous lessons, how do we find all the possibilities is multiply all of them, right? Now imagine over here they have given an example of different music tracks, okay? There are playlists, 7 track playlists. Now, what are the all possible ways to select them? Now, when you select them, the first possibility would be all 7. You can select any one, all 7. But then once this is done, how many remain? 6 for the second song, and 5, and 4, and 3, and so on, right? Instead of all that, what we will do is we'll consider it to be 7 factorial. This means first you multiply this number 7 and then 1 less than that. It goes n minus 1, that's 6, multiplied by n minus 2 now. N is this, 7, n minus 1 is 6, n minus 2 is 5, and so on until you reach 1. Okay, you don't multiply with 0 when you reach 1, that's the thing. And if you're thinking what is 0 factorial, it is equal to 1 as well. Okay, so factorial is an easy way to solve these problems. And now if you're thinking about the formula of NPR, which we saw just a while ago, this is the formula here. NPR, see, there's various ways to write it. Now one way is N over here and then P caps P R like this, or some write it NPR, or they write it down NPR. You can write superscript, letter, subscript, normal just letters and small letters, or subscript. Subscript means anything that is down here. Superscript is something that's up above over here. Now then, let's see if you have, see, this is the formula, let me write it, NPR. Then we need to start with n factorial divided by n minus r factorial. Whenever we use this formula and whatever the answer we get, here the order makes a difference. Order is important. So this is the NPR permutation formula. And now if you have any numbers over here, you can see 7 and 4. The n will be more than r generally, because most of the problems, n is the total possibility, total number given to you. In a problem, it will be more clear. And r is the selection. So you just put in this formula and you get the answer. Now we'll jump into a problem and apply it. Before we start this problem, let us remember, what is probability? Probability of any event. It's always the desired outcomes divided by the total outcomes. I hope you remember this. Total outcomes. Now, desired is what you want, what happens, which is the favorable outcome or what you really want to happen. This is all the total possibilities. The permutation is basically the total outcomes, total possibilities, not the desired one. Desired one is what you need to read the question and understand and write it out. Let's read this question now. Taisha and Liam sign up for an open mic night with 32 available slots that are filled at random. What is the probability that Taisha will perform first and Liam will perform second? Now here, what is the desired possibility we want? We want Taisha to perform first and Liam to perform second. And there are total 32 available slots. Out of 32, the first one must be Taisha and second one itself must be Liam. How many possibilities can this happen? There's only one possibility. It's like, Taisha must be first, Liam must be second. This is just one possible way that can occur, right? So desired over here is 1. What is the n value? The total availability is n, that is 32. R is the selection. Over here, Taisha and Liam, there are only 2 people, so R will be equal to 2. So now over here, the total outcome will be n, that is 32 P2. This is the answer. Now here, you can solve by using the formula, that is n factorial by n minus r whole factorial. Now this factorial, everything can be solved in calculator. Now if you know this formula, you can just write it some way and then you can directly use the calculator and solve it. What I would suggest is, if there's plenty to write, so what you can do is you can just write NPR equals this formula some way, and no need of using it. If you know the formula, it's more than enough. You can just directly, put it in the calculator, which I'll show you now. Now I will solve this individually. First, 32. Where is P? P is by shift and this over here multiplication symbol. That's the P value. If it is C, it's shift and division symbol. And R is 2. This is the total possibilities. But here we have 1 divided by, right? So you can just write it like this. 1 divided by 992 was what we got. But let me just write it. 32P2. I wrote C, sorry, that's wrong. It's P2. It's 1 by 992. That is the probability. It's 0.001. If you want the percentage, you just multiply this by 100. You will get the percentage over here. Just multiply by 100. That's the percentage. It's like 0.1%. Now just imagine there are total possibilities, total 32 possibilities, 32 slots available, and you expect the 2 specific person to perform first, one person to perform first and next person to perform second out of all the 32 available slots. It's such a rare case. It's like 0.1% that might happen. Okay, always when you get the answer, try to relate and understand to the given situation, and you can understand whether it's true or false. So this is the answer. You can write it in fractions itself. So I'll just remove it. It's 1 by 992. Let's over here they have used some other method, I guess. That's fine. The final answer will be the same. Why I told you this method is desired by total outcomes. Whatever you saw over here can be used all the time and you will definitely get the correct answer all the time. So just stick to one probability method every time. If it's for combination, it's just the formula that changes. Now we will look over here. 5 geometry students are asked to randomly choose a polygon and describe its properties. What is the probability that the first 3 students choose hexagon, the pentagon and triangle in that order? See, now it's very important. There is an order over here. Hexagon is chosen first, pentagon next, and then the triangle. No matter what, all the 3 students must choose the same order. order is important. It's permutation problem. We can understand it easily. But now, what's the answer? Probability would be equal to, I'll write desired by total. This D is for desire divided by total. Now, what is the desired? Hexagon, pentagon, triangle, all must be in order, right? It's only one possibility, one desired outcome because there is no more. Only this is the exact way to select. So it's only one possibility divided by. Now, what is happening? There are five geometric figures, right? There are n is 5, p, r is the selection. How much is the selection that's made? 1, 2, 3. So it's 5p3. So you just put this in the calculator, you should get the answer. I'll use the same one, just change r to 3 and n to 5 here. The answer must be 1 by 60, and that's it. So this is how we can easily solve it up. Now let's look into another problem. Here for a project, Rami selects 12 family photographs which will randomly play in a slideshow. The slideshow will not show repeat photos until all 12 photos have been shown. That means each order is important. After one, the other one, and so on. Three photos are of Rami's entire family, two are of his brother, three are of just him, and four photos are of his sister. What is the probability that the first four pictures in the slideshow will be Rami's sister? So now here, first thing, what is n? Let's note down a few things. That n is 12. This is not odd. This is saying how many photos are there. Three photos are of his family, two are of his brother, three are of him, four are of sister. What is the probability that the first four photos are is 4 here? This is the selection what we want. Okay, are only of Rami's sister. Now here there is an important thing to remember. In the previous problems, it was only one possibility divided by the permutation, right? Here it's not like that. Desired by total, right? This is the probability of any event. What is the desired over here? It's his sister's photos. How many photos are there? There are four photos. So the first possibility is out of four, any one can be chosen. Then, once one is chosen, how many more possibilities are there? Three possibilities. Then again, there is two possibilities. And lastly, there is one possibility. Because there are four photos of a sister. So you can directly write it as 4 factorial. What is the total? N is 12, P, R is 4. So I'll just change this N to 12 over here. So one more thing, when you're solving it directly, write what is NPR, n factorial by n minus r, the whole factorial. That means you know the formula. You can use the calculator itself to solve this formula. So just write it out. But now we will directly use the calculator and solve it. I'll just change this up over here. It's 4 selections, that is R is 4 and N is 12, the total number of photographs. And what is the desired one over here? It's 4 factorial. Now, where do you find factorial is? Shift and the symbol. It's about the x inverse, that's by shift and x inverse symbol gives you it. Now it's 1 by 495, that should be the answer. And over here, yeah, that was the answer, I guess. It's 1 by 495. Now here the total possibilities are 11,880. Yes, but we are, having 4 factored in the numerator, so it becomes 1 by 495. Now if they just ask you what is the total possibilities, this is the answer, 12p4. That's it. And now we will see another important type of problem, that is permutations with repetition. Before I continue, a quick reminder, please do consider subscribing to my channel. If you have subscribed to it, thank you so much. And please do like and share my videos. I would love it so much. Thank you, guys. This is another interesting topic, permutations with repetition. Now imagine, we'll just go to an example and then we will see what exactly repetition would mean. Imagine you have the word cat. How many different ways you can arrange it? It's basically 3 factorial, right? Because there's 3 possibilities. So it's either CAT, CTA, or then now take A, it is the first letter, then ACT or ATC, and then lastly T, TCA or TAC. This is 6. Now, what about the letter MOM? Because there are three letters, it should be 3 factorial, isn't it? But now let's try it. It'll be MOM. I will write MMO, or I'll bring this O to the first. And now, doesn't matter what I do, these are both the same letters M. So, doesn't matter, I flip this, it's the same thing, isn't it? M and M, even if I swap them, they'll be the same thing. So, here the numbers are repeated. So, how many possibilities? Only three possibilities. How do we know? So, the formula is very simple. Total number, that is n factorial, that is what we do for general problems if there is no repetition. But if it's repeated, divided by the number of repeated letter. What is it over here? M is repeated how many times? The number of times it's repeated, sorry. It's 3 factorial by 2 factorial, that is 3. That's the answer. Now, any other letter, count the number of repeated alphabets and then solve it up. Here, one more thing. Please avoid using NPR formula. There is cases where you can use and solve it, but it's just complicated. So I will tell you the easiest method. So just avoid NPR formula when it comes to repetition. Now let's look at this problem. One game show has contestants arrange 5 number tiles to build their guess at the price of a prize. Mishka is given 5 tiles with the numbers 2, 2, 5, 5, 8. If Mishka arranges the tiles randomly, what is the probability that she arranges them as correct price of 25,852? So this is the exact number. This is the price that must be arranged. Now, what are the possible ways that this number is exactly arranged? What is the probability or what is the chance? Yeah, how many total numbers are there? 1, 2, 3, 4, 5 factorial, right? But what happens? 2 is repeated 2 times, so 2 factorial. It's not because of this number. How many times is repeated? If it was another 2, 2, 2, 2, I should have written 3 factorial here. The 2 is repeated twice. And what about 5? Again repeated twice. So it's 5 factorial by 2 factorial. So this is the answer. This is the total possibilities that these numbers can be arranged to the correct number. Now, getting the correct number is only one possibility. Probability is always desired by total, isn't it? Now, what is the desired over here? This is desired by total. Desired is only one because this should be the exact number. That is the desired. So it's only one possibility. And total is basically over here, whatever the answer you get. Okay? I'll just write it over here, 5 factorial divided by 2 factorial into 2 factorial. You can put this everything in the calculator directly and get the answer as well. But what I'll do is I'll just find this probability, this 5 factorial divided by 2 factorial into 2 also you can do, or I'll just write it 2 factorial itself for this one. The answer is 30. So it is 1 by 30. There is a chance of 1 by 30 times that this actual number can be guessed out. Okay. So the answer is 1 over 30. Let's look at another problem. The physics team is holding a game night fundraiser to win a grand prize in a particular game. You must spin the spinner 4 times and land on blue, red, green, and yellow in that order. See, this order is very important. Blue, red, green, yellow. Order gives out that it's permutation. What is the probability that you will spin the winning sequence? Now, how many possibilities are there in total? Let's count. There are 3 blues: 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is basically 12 here. The total. Let me write 12 factorial. But what is repeating here? 1, 2, 3. Blue is repeated 3 factorial. What about red? 5 factorial. Why? Because 1, 2, 3, 4, 5. And what about the green? Again 3 factorial. So this is the total possibilities. And now if you want to put the winning sequence, it should be blue, red, green, yellow. It's only one possibility, isn't it? Probability of event is desired by total. So here the desired, what is desired exactly? It's only 1 divided by whatever this answer you get. Here, let me just change it up. Instead of 5, we have 12 factorial divided by 3 factorial multiplied by 5 factorial. And again, last we have 3 factorial, shift and inverse. So it's 1 by 110,880. So this would be the answer. It is 110880. So it's 110,880. So it's a very, very rare scenario. That's how we solve this particular problem. Now we go to probabilities using combinations. This is another interesting one. Here the order is not important. If the order is not important, imagine you need to select these three balls just like how we did in permutations. Now let's do with combination. Select them here without any order. So one way, see over here, if it's a red, black, red or red, black, it's the same thing. It doesn't matter. Here, this was for the permutation, sorry. We used to see the order is very important and it was six possibilities for permutation. Just now we saw this. But now for combination, it doesn't matter. This is the same thing. One possibility is red and green. Or even if it is green or red, it's fine. It's the same thing. Or it can be red and black or red and green. That's it. These are only three possibilities because here, whether it's black or red and black, it's considered the same thing. After all, they're the same balls, right? You're just arranging the position or the order, which is not important in combination. So that's the thing. The probability using combinations is given by NCR. It is not P over here. Permutation is P, NCR. This formula is given by N factorial by R factorial into N minus R, the whole factorial. Or sometimes you can write it like this also. It's the same thing what I've written. NCR is equal to N factorial. I've just written R first. I usually write R first, but it's fine. N minus R, the whole factorial into R factorial. It's the same thing. Again, you can directly solve this in calculator, but please do mention this formula, and then what you can do is you can directly solve in calculator. We have an interesting problem here on combinations. If 3 points are randomly chosen from those named on pentagon A, C, E, G, J, what is the probability that they all lie on the same line segment? Let's count the total number of points. How many? It is 3, 6, 9, 10 points are there. So n is 10. Now, before that, again, probability of any event is given by desired by the total. So desired and total over here. Desired will come to it in a while. This total is given by NCR, isn't it? This NCR, what is the N value over here? We just now counted N is 10, C. And what are the, what is the selection? 3 points are randomly chosen. So the selection is 3. That's it. Here it's given 3 points are randomly chosen. Now, what is the desired outcome? What is the probability that they will all lie on the same line segment? That means the 3 chosen points can be JKA. Okay, it doesn't matter the order. It can be A, K, AKJ or KAJ or anything. Or then another possibility is ABC, or another one is CDE or DEC or C, any order is fine. And then we have EFG, and lastly again we have GHA. So how many lines are there? 1, 2, 3, 4, 5. So there is totally 5 possibilities. Now let's write the formula for NCR. It is given by N factorial divided by R factorial into N minus R, the whole factorial. Or you can write N minus R factorial into R factorial. We will solve it up in the calculator directly. 5 divided by 10. C is over here, shift and division symbol, and R is 3. The answer is 1 by 24. So over here you can see the final answer is 1 by 24. If you do 10C3, it is 120 possibilities. But now here we have 5 desired outcome. So it will be 1 by 24 as the last problem in this lesson. It's about a lattice. A lattice is a point at the intersection of two or more grid lines. You can see over here, whenever grid lines intersect, that is a lattice point over here. All these are lattice points. Okay. If two lattice points are chosen randomly in rectangle ABCD, see ABCD, the outer rectangle, the orange color one. Now, orange color is entirely this entire thing, okay? Whereas WXYZ is only the green one. Now, two are being chosen randomly in the rectangle ABCD, including its sides. The probability they are in rectangle WXYZ, including its sides, is now here you're just choosing two random points in within this triangle, okay? Any two random points. But what is the probability that they fall within this rectangle? It's all squares over here, but still square is a rectangle itself. So they're just mentioning rectangle. It's fine. Now, what is the desired and total? So in such problems, right? You can use NCR and PR, but what I would personally do is, since it's countable over here, you can just start counting it. Now, when you have such graphs, such problems where lattice points are to be considered, what is the total lattice points? You can count the sides and multiply, but I will just mark out all the points to make it easy. So, what is the point over here? 1, this is a lattice point. 2, 3, 4, 5, 6. And again over here 7, 8, 9, 10, 11, 12, and it goes on. So you can do one side and one more side. 3, 6. So 6 times 6 would be 36. Or you can just count them all. Count them all. You will get 36. See, these are all for the rectangle A, B, C, D. So these are all the lattice points, isn't it? So that is n. N is equal to 36. What is the selection? Selection is R. R is how many? Two lattice points are being selected. That is 2. Now let's write the probability formula. Probability is given by desired divided by total. And what is desired over here? Now again we need to count them because desired is within this rectangle. How many are there within the rectangle WXYZ, the inner rectangle? Let's again count. Say this would be 1, 2, 3, 4, 5, 6, 4 and 4. It'll be 16. Okay, if you these are the ones in blue. Now for ABCD all are included. Okay. Now desired would be 4 fours are 16. Now here again remember 16 what? Is it just 16? No, it is 16C2. Why? Because all these are possible, right? Two are being selected, either this or this or this. There are various possibilities. So all 16C2. Over here also you need to use combination. And what is the total? Total is basically 36 is N. We have got C2. Just put this in calculator. You will get the first answer. And now what about the next one? Let's write it and then I'll use the calculator together. This was supposed to be written up. Okay, this is over here. And the next one probability would be desired by total. If four lattice points are chosen randomly in the rectangle ABCD, so again for the total the n is same 36, only the r value changes. How much is r? R is 4 this time, including its sides. Yes, the probability that they are WXYZ. So now they are telling what is the probability that will be W or X or Y or Z. So these, what is the probability that they will be these four particular points? It's only four possibilities, right? Sorry, I'm wrong. Four are being selected. They must be four. It is basically one possibility, okay? One possibility. But if you're thinking, okay, I will write in terms of NCR. Okay, yes, you can do. There are 4 points over here, possible points, and you're selecting 4. 4C4 is 1 basically. Okay, this is the way to write. I've written 4C4Y because I've written this as 2, right? So that's the reason. Over here also I've written 16C2. That's the reason. Or you can easily understand WXYZ. 4 points also have to be selected. Only one possible way. That is 1 over here in the desired outcome. So now we can just put this in the calculator and solve it up. The first one is 16. C is by shift and C 2 divided by 36 shift C2. The answer must be 4 by 21, yes. And you can find the percentage by multiplying by 100. Over here it'll be decimal will go 2 to the other side, it'll be 19%. Now the next answer would be over here 4, and even over here it'll be 4C4, or 1 you can write it. It is 1 by 58,905, or if you do it as percentage it'll be 0 point, it's negligible, so just keep it as fraction itself, because it's such a huge number, it'll be 0.00 so on, right? So this is the answer, 58,905. I hope this is clear. Please make sure you understand permutation and combination problems, because they won't tell you this is permutation or combination problem. Looking at the question, you need to understand it. Use the appropriate formulas. Combination for where the combination is for the problems where order is not important. Permutation where order is important. And please try to remember probability is desired by total outcomes. Stick to that same formula and you can solve all the problems. Before I end, please do subscribe to my channel. Please do like and share my videos with your friends. I would really appreciate it. Until the next video, I wish you all happy learning.